Hello, and today we're looking at the proof for the power rule. This is probably one of the first things taught in calculus um, after differentiation from first principles. And actually we're going to start with differentiation from first principles. If you recall the formula, we have the limit as h goes to 0 of f of x plus h minus f of x over h. And we can start with substituting x to the n to this formula. And then we can write x plus h to the n as a binomial series. So we have the sum as from 0 to n of n choose r, so the binomial coefficient, times n x to the n minus r times h to the r. Now what we can do is we can look at this summation, and if we extract the first term where r equals 0, we can take the sum from r equals 1 to n, and then we add the sum where r equals 0. So we add the sum of n choose 0 times x to the n times h to the 0. So it's n minus 0, which is 0. And we can simplify this a lot by considering the first column of Pascal's triangle, which consists of only ones. So this is going to be 1 times x to the n times h to the 0, which is also 1. So we get this, and x to the n minus x to the n cancels out, and we get this nicer expression. This nicer expression can be simplified further if we consider the sum from r is equal to 1, r is equal to 2, sorry, to n. So if we consider the sum from r is equal to 2 to n, we can write the r is equal to 1 term as n choose 1 times x to the n minus 1 times h. And if we split the fraction and distribute the limit, we get this. N choose 1 is always going to be n if you look at the second column of Pascal's triangle. Now the h's obviously cancel out, and the limit as h goes to 0 of the expression on the right just goes to n times x to the n minus 1, since there are no h's on the right anymore after these two cancel. So now if we look on the left, we can factor a h squared from this whole summation, and we can do this because inside we're going to get h to the r minus 2, which r goes from 2 to n, so this could be h to the 0, but it can't be h to a negative value. So now we can cancel out one of the h's, and we get the limit as h goes to 0 of h times this big expression, which is, you can just think of as a bunch of binomial terms, and all of these binomial terms are going to have a h term in them, and this h term is going to go to 0, so this whole expression is going to go to 0. So overall, we get the derivative of x to the n is equal to n times x to the n minus 1. Thank you for watching.